Today, we'll explore the fascinating world of computer architecture, focusing on instruction sets, addressing modes. By the end of this video, you'll understand various addressing techniques that enable processors to access and manipulate data efficiently. In this video, we'll describe different types of addressing modes commonly used in instruction sets and understand their advantages and limitations. Addressing modes define how an instruction identifies its operands. They include methods like immediate, direct, indirect, register, register indirect, displacement, and stack addressing. Let's dive into each of these. Immediate addressing is the simplest form. Here, the operand is directly specified in the instruction. It's ideal for constants or initializing variables. While it's fast, as it doesn't require memory access, the operand size is limited by the address field. For example, you might use an instruction like add R1, 5, which adds the value 5 directly to register R1. In direct addressing, the instruction provides the effective address of the operand. While it's simple and requires only one memory reference, it has a limited address space, making it less versatile for larger applications. For example, an instruction add R1, 1000, where 1000 is the memory address containing the value to be added to R1. Let's look at indirect addressing. In this mode, the address field in the instruction points to another address in memory, which contains the operand. This provides a large address space, ideal for more complex programs. The main advantage of indirect addressing is its ability to access a larger memory space. With n-bit addressing, it can handle 2 to the power of n locations. However, this mode has a downside. It requires multiple memory accesses to fetch the operand, which can slow down execution. Example, 2 memory access is needed to fetch where one is to get the address and a second one is to get the value. Here is a real-life example to help you understand further. Imagine you've ordered a parcel online, but instead of the delivery service bringing it straight to your home, they send you a pickup slip with an address where your parcel is stored. You then has to go to the location where the address located. Then you hand over the slip and the clerk will finally fetches your parcel. Here's how the process works. You receive the slip, this represents the instruction in the program. The slip contains the address of the post office where your parcel is kept. You go to the post office, the memory address indicated on the slip. You hand over the slip to the clerk fetches your parcel, the operand stored at the memory address. To break down better, pickup slip equals address A in the instruction, post office equals memory and parcel equals operand. Next, we'll discuss the register addressing mode in computer architecture. In register addressing, the address field refers to a register instead of a main memory address. Here, the effective address is simply the register specified in the address field. One advantage is that only a small address field is required in the instruction. Another advantage is that there's no need for a time-consuming memory reference. However, the main disadvantage of register addressing is that the address space is very limited. This diagram represents the process of register addressing mode, where the instruction refers to the operand stored in a register. Here's an example of the register addressing application. Let's say you want to add 2 numbers in a program using assembly language. Instead of directly accessing memory, the processor uses registers for faster computation. Load the first number, 5, into a register 1. Load the second number, 7, into another register. Perform the addition operation using the registers. Store the result in a third register. The next one is register indirect addressing. This addressing is similar to indirect addressing, but the address of the operand is stored in a register instead of memory. This approach combines the speed of registers with the flexibility of indirect addressing, as it requires fewer memory references. Firstly, the instruction will refer to a register that contain the memory address. The effective address is derived from the contents of the register. However, it still involves at least one memory access to fetch the operand. Then, with the memory address from the registers, it will refer to memory and find the operand. This would be the process of register indirect addressing. Okay, now we will continue with the displacement addressing mode. This addressing mode is a versatile mode that combines the capabilities of direct and register indirect addressing. The effective address is calculated by adding a constant value, or displacement, to the contents of a register. Then, the value calculated will be an address for the operand in the memory. This mode is highly flexible and is commonly used for relative addressing, base register addressing, and indexing. While displacement addressing offers great functionality, it requires more complex instruction decoding, which can increase processing time. Now, we have reached to the last addressing mode, which is stack addressing. This addressing uses a data structure called a stack, which works like a last-in first-out LIFO queue, meaning that the last item added is the first one to be removed. Think of it as a stack of plates, you always take the top plate first. The stack is a reserved block of memory locations, and items are added, or pushed, to the top and removed, or popped, from the top. To manage this, a stack pointer is used. This pointer, stored in a register, keeps track of the address of the top of the stack. As items are pushed or popped, the pointer adjusts automatically. Because of this setup, stack addressing is a type of register indirect addressing, where the stack pointer indirectly points to memory locations. In conclusion, immediate addressing directly uses the operand in the instruction, avoiding memory reference. However, it limits the size of the operand. In direct addressing, the effective address is the address field itself. It's simple but provides limited address space. Indirect addressing allows for a large address space by using a pointer, but it requires multiple memory references. Register addressing is fast as it avoids memory reference but is constrained by the limited size of registers. This mode uses registers as pointers to access a large address space, though it adds the overhead of extra memory references. Displacement addressing is highly flexible, combining base and offset addressing. However, it can be complex to implement. Stack addressing operates at the top of the stack, avoiding memory references but being limited in its use. These addressing modes form the foundation of how computers access data. Each mode has its unique strengths and limitations, tailored for different applications.